All right, good afternoon, everybody. If you guys can hear me and if you guys can see the screen, just confirm. And we're gonna jump straight into today's session. All right, so we're gonna begin. So last week we started off with vectors, and so our aim today is to just finish going through the general concept. One of the things I like about vectors is pretty straight to the point. It's pretty um, repetitive. So once we get through the concepts today, we can start looking at past paper questions immediately. Actually, vectors and matrices are connected. So once we knock out vectors and matrices, it's... Oh, hello, can you hear me? Okay, so what I was saying is that vectors and matrices, they come in one question. That's question 10. So what we're going to do is try to knock off everything on the vectors so that we can move right into matrices and then we could get into the practice questions. Because to be honest, once we cover the basics and we start looking at the questions, we would realize how simple the concept is and everything that we need to know. Sounds good? Okay, so let's jump straight into it. So I asked you guys to finish this for homework. Not sure if you did get a chance to, but we're gonna jump into it. So based on what we did last class, we understand that vectors is just a movement from a beginning point to an end point. So if we look at this example here, let me zoom in a little bit more. So we're looking at this diagram that has vectors. And if we look at it, remember what indicates a vector? A line with an arrow. It always has a beginning point, and an end point. So they gave us the vector representation AC, and you have to use the common letters to dictate how you're going to move from one point to the next. So let's look at how they got from A to C. So where is A? This is A. Where is C? This is C. So obviously you have two ways you can go to get to C. You could move in the direction of B. So as you realize, this entire line is represented by B. And then this is going to take you to point B. And then if you travel along C, you get to point C. Everybody understand the basic movement of the vectors in this case? So really, The vector equation uses the common letter to tell us how to get from the starting point A to the ending point C. So that's how they end up with B plus C. Now, for those who did not see class or were not here for class last week, I just want to remind you guys something. Let's say I have a vector going in this direction and I call this vector A. If I have a line that is parallel but going in the opposite direction, it will be called, anybody remember what it's going to be called? It's going to be called negative A. So the same line, keep in mind, is the same line, except if I want to go from one direction and the front direction is A, if I want to go in the opposite direction, it's going to be called negative A. So even though this is the arrow, if I want to go backwards, it's going to become negative A. Everybody with me so far? So let's take a look at the information and the questions, and let's work through the questions together. So this is the diagram, and the truth is this comes a lot in CXC questions. They give you a diagram and they're going to ask you to write the vector equation of the vectors that they ask you for. So let's take a look at AD. So based on AD, the starting letter is what? A, and our destination letter is D. So let's look at where those 2 points are located. So let me just bring this down so we can see a little better. Everybody seeing the diagram? So let's look at where we're beginning and where we're ending. So always make sure you identify those two things. So I'm starting at A and I want to end up at D. One of the things you should realize is that this specific line, we cannot travel along this line, because what do you realize this line does not have that every other line has? It does not have an arrow. That means that line is not a vector. It's just a regular line. What makes a vector? It must have a direction and it must have a value. And as we see here, every other vector is labeled with a value represented by a common letter. Okay, so this is just me quickly recapping some stuff we did last class. So for those who did not make it to Thursday session, I recommend that you look at Thursday recording. Okay. All right, so let's go. We want to go from A to D. So one of the things we need to always remember, we could go two ways. We could go the short way by taking A to O, O to M, then D. Or we could go the long way by going all the way around. So I am going to do both ways because for me, it's important that you guys can do both ways. So let's do the short way first. All right. So if I want to go from A to D, I got to pass through some points. So let's go. I am going to go from A first to what letter? What's the first letter we should go to? We got to go to O. And what letter represents that movement from A to O? A common A. So I am just going to write A because that's the line I travel first. Before I continue, everybody with me so far? So the first part of the equation going to be, I started off at traveling the line or vector A. Talk to me, talk to me, talk to me. So Janella says yes, Gwen says yes. Okay, just let me know, okay? Follow me. Now let's go. We reach O, but keep it in mind where we need to end up. We need to end up at D. So I'm going to travel along from O to M. Let me use yellow again because yellow is brighter and we could see it. So I'm going to travel along OM. So this is where I end up now at M. What letter represents that movement? Based on what we just did, that represents what? E. And because we are going along the arrow, we know it's going to be plus E. Everybody see that? So now that we are at M, we want to go to D, but look at what's happening with the arrow from M to D. The forward letter is F. So if I want to go in the opposite direction, what would the opposite direction be? The opposite direction would be negative F. So I will use my yellow line just to make sure we understand. So I'm going this direction, which is the opposite direction of F, which would give me negative F. So what am I going to write? I'm going to write minus F. Everybody with me? So that is how you write your vector equation. You look at the vector notation that tells you the beginning letter, the ending letter, and you follow along the path until you get there. Now let's do the long way. So that's one way. So I'm going to put a dash, and now we're going to look at the other way of finding the vector equation to get from A to E. If you choose any way, to be honest, you will get max, but obviously you will try to get one. That's the easiest. So let's go the long way. What do I do? So I gotta go from A to B first. And what letter represents that? We're going in the right direction, so that will be positive B. Everybody agree so far? So let's keep it moving. Now I'm gonna go from B to C. What letter represents that? And you realize it's the positive direction. So all I need to do is what? Add C plus C. Now, watch what happens now that we're at C. I need to move through M, then to D. But you realize the arrow is going the wrong direction. So it means then I need to go in the opposite direction of positive D, which is, let me just move my diagram over or down. So instead of plus D, it's going to become what? Minus D. Similarly, this takes us to M. So now we need to move from M to D, and we realize the arrow is not going in the direction that we want. So we need to go to the opposite direction, which would means we need to do what? Minus F. And that's it. That's how you write the vector equation. Everybody with me? So I see we have Cloris and Ajani who weren't not here, but just let me know if you guys are okay. We're going to move on now to OD. So let's again identify where O is. This is where O is. And we need to go to D. So let's go. How do I get to D? So everybody take a try. What would be the first letter we write for OD? Okay, Janella says E minus F. Everybody take a look. Do you agree? So let's follow along the lines. So remember, again, what is this notation in the table represents? That we're moving from point O straight to D. And in order for us to get there, we need to take some paths. So we're going O to M first, which is represented by E. So that's correct. And why is it positive E? Because we're going in the direction of the arrow. Now that I am at M, I need to get to D. And if you realize currently F represents a forward movement. So if I want to go backwards, what do I get? Minus F. All right, we okay? We looking good? Let's continue. Now we need to get what? BO. Let's go. Where is B? So you look for B. This is where B is. Where is O? We look for O. Now you have two options. You could go backwards, then up, or upwards, then across, and then down. So which one you prefer first? The shorter way, right? So let's do the shorter way, which is just going straight back, then up. So let's go. If I want to get to O, I need to get to A first. So what letter represents that movement? Is it a positive B or a negative B? Everybody, try that one for me. What should I write down first? Excellent. Negative B. Very good. So this takes us to A, but keep it in mind, where do we want to end up at? We want to end up at O. So now that I am at A, how do I get to O? Is it a positive A or negative A? Excellent, excellent. So it's going to be plus A. Very good, everybody. Pretty simple. And that's something you guys need to keep in the back of your minds, that this concept is simple. It gets more challenging, obviously. And I'm going to show you some examples where they get challenging. But just based on my experience, vectors is pretty simple. So let's go. BM. So let's just erase what we have so far. We want to get to BM. Where is B? This is B. Where is M? This is M. So let's just take this pathway. What would be the pathway to get to B, everybody? What would be the equation? The first part going to be what? And I need y'all to respond a little faster so we could get through this. So what will be your first path? Negative C or just C? Very good. It's just going to be C. And that's going to take us to here. And then how do I get from C to M? Since we're going in the opposite direction, it's going to be, finish it. Excellent. Minus D or negative D. Yep. All right. Last one. We want MA. And I hope everybody remember, there's no time you could travel along this line. No time at all. Because it is not a vector. So let's go. We want MA. So let's go identify. This is our M. And I want to get to the A. Anybody want to try? Very good, Gwen. Very good. Excellent, Ajani. So we're going from M to O, which is negative E. Very good. So it's going to be negative E. That's going to bring us here. And how do we get back to A? Is the opposite of A, which is minus A. Yup, that's it. That is it. So based on this activity, how are we feeling about vector notation? And I'm going to tell you guys, questions like this comes a lot. Obviously, like I said, a little bit more complicated, but how everybody feeling about vector equations? All right, so we're going to move right along because like I said, our aim is to finish understanding all the content so we could start looking at how it comes in questions, because it's more important to know how to apply the information than just knowing the information. All right, hi Ash. Okay, so let's move on. So now that we know vector equations, we are good to go. That's a huge component of the exam. And so I'm very happy that everybody feels good about it. Those persons who are late, no worries. We're going to have a lot of practice with those questions. And so if you missed it, no biggie. All right, so let's take a look here. This is another very important concept. Parallel vectors and equal vectors. Now it's pretty simple. As we learned, I'm just going to use my own summary before I go to the actual notes. As we learned, there's 3 ways to represent a vector, using the beginning point and the end point with an arrow. And remember, the arrow is what makes it a vector because it tells us that this vector is moving from A and it goes to B. So that's one. The second one is using a common letter to represent the vector. And as we see in the previous example, how this works. So vector DM is represented by F, MC is represented by D. Okay. The next one is your column vector or your column matrix, where the number to the top is always your X value. The number to the bottom is always your Y value. And keep in mind, this is something that's also important. Whenever they give you a vector like this, X represents what happens to the X axis, obviously. Y tells you what happens to the Y. When X is positive, anybody know what that means? That means X is moving from left to right. So it means that X is positive, it moves to the right. So let me ask you a question. If positive means, or plus means move to the right, what do you think a negative X means? What direction you're going to be moving? Let's see if we're thinking. Very good. You're going to move to the left. Because remember, a vector is something that's moving, eh? Remember, it's always moving from one place to the next. So you have to keep in mind that if the X is positive, that means the vector going this way or up this way. But either way, it's moving towards the right. And if it is negative, you know the vector is pointing where? To the left. That's all it means, okay? So similarly, if on the X-axis we have left and right, what do you think the Y-axis can give us? Based on what you already know about the Y-axis, what do you think the Y-axis is going to give us? Up and down. Agreed? Very good. So what would be the plus based on what you understand? I'm not going to tell you guys try. What do you think the plus represents? Which one? Very good, up. And so the negative would be what? Down. No, what I love about this, guys, what is very important, there's certain things you need to be able to figure out. It's almost like you realize everything in maths connected. So these are things that you have to start noticing. Obviously, if we on a graph and if something is moving in a positive direction, it means that it's increasing. So it has to be moving to the right. Similarly, if you're increasing on the Y, you must be going up. All right. So these are the things we need to keep in mind and also be very, very, very careful with. All right. So taking this into consideration, let's say I have a vector 2, 3. And let's call this vector M. Let's say I have another vector N, and the vector is 4, 6. Can anybody pick up a connection between M and N? Is there any relationship y'all realize between 2 and 3 and 4 and 6? Anybody? Look at the numbers. Exactly. Multiply or multiple of 2. Everybody seen it? And it means then that it's very easy to identify. So guess what? This just simply means that N is equal to 2 times M. Right or wrong? Everybody agree? Because what is N? N is 4, 6. And 2 times M. What is M? 2, 3. So if I take 2 and multiply by the two numbers, both X and Y, we're going to end up with 4, 6. Guess what? Anytime two vectors are connected by a number like this, they are parallel. So once one vector is a multiple of another vector, they are parallel. Everybody see that? So look at how I just teach y'all that so quick. Everybody with me? So let's look at the notes now. Remember, I sent you this document for a reason. It's important for you to have this printed because you can use it for practice. And what I like about it, it has a lot of question practice. It has all the answers. So you could always try them by yourself and look at the answers and see if you could get them right. Okay. So let's look at this question here. This is the law here. It says vector C is parallel to vector B if C is equal to KB. And based on our example, what was our K? Our K was 2. Everybody see that? Because we multiplied B by 2 and it would have given us the other vector. So let's take a look at an example here. Example 1. We have 2 vectors, vector B and vector C. Just by looking at it, before we prove it, what do you guys think? Do you think they're parallel? Yes or no? Even if you're not 100% confident. Very good, because guess what? There is a number I could multiply by 4 to get, oh, very good. If I multiply 3 by 4 and I multiply 2 by 4, it gives me this vector here. So what is our K in this example? Our K is what? Our K is 4. Everybody with me? So now that you kind of understand the concept of 2 parallel vectors, the only thing you need to learn is how to write down your answer for the proof. So this is what I want you to pay attention. Remember, I spoke to you guys about using language in maths. You have to give your sentences. You have to explain what you're doing. Anytime you have to prove something, you have to start saying, if this is this, then that, or so, or therefore, or if this, then that. So let's look at how you have to break down your answer. And this type of question comes a lot. This question that is always asked you that. They're going to be like, this is point, this is vector this is vector that, or this is point this is point that. Prove if they are parallel. So let's go. we would say now or since 12(8) can be written as 3, 2, because you realize they identify the number you have to multiply as to get the vector. What do you realize they did? They said C, which is this one, is equal to 4 times B, which is this one. Therefore, K is equal to 4. So B and C are parallel. This part ain't necessary. Why is this part not necessary? Aren't these two things the same thing? 4 times B, we learn in algebra as well. Ain't 4B. Everybody talk to me. So I'm going to do a next example so we could practice how we need to explain our answer. But similarly, we actually did it before, but we're just going to make it a bit clean and nice. So let's try another one. So let's try, I give you a vector P, which is equal to, let's say 1, 3. And I give you a vector Q, which is equal to 3, 9. And the question I'm going to say, prove that P and Q are parallel. So the first thing I'm going to ask you, just by looking at it, do you guys think it's parallel? Let's go, everybody else. Let's go. Let's go. It's important for me to know if you're seeing it. How do you know if it's parallel? Is there a number I can multiply by P to get Q? Yes. What is that number? 3. So you would say, since Q, because remember Q is the biggest one, you always put the biggest one first. Q, what is Q equal to? Isn't Q equal to 3P? Right or wrong? So you would say, since Q is equal to 3P, where, and you make sure you explain what you mean. You write out what is Q, which is what? 3, 9 is equal to 3 times 1, 3. One of the things you must say is what is K. So since you proved this part, what's the next thing we need to say? Then what? Since that is the case, then K is equal to what? K is equal to 3. And the last thing you need to say is what? Therefore, P and Q are what? Parallel. Everybody see now? Guess what? That's it. Once you can prove that one is a multiple of the other, that's it. So I actually want you guys to copy down this example in your notebooks, because this is not on the handout. This is just an extra question for practice. So please, and the topic here is parallel vectors. So copy this down and tell me when you guys are finished. I just want to take this opportunity to let you guys know that one of the things you need to remember is that the content is easy. But what do you think is important? Practice, because with practice, you would remember. Now, I'm not seeing as much persons as I would like to see on our Sunday sessions, which is the past paper sessions. We have, as of today, well, tomorrow is going to be 99 days until the exam. So we need to kind of make some extra effort to come to the Sunday sessions. You know why? We're not going to wait until a week before the exam to start revising past papers. We don't start. So far, we've covered question 1, question 2, question 4. This Sunday, we are moving on to question 5, which is our statistics questions. So please make an extra effort to attend. Starting next week, we start in paper 1. And what I'm going to do, I'm going to send each of you the paper 1, and you're going to try to work it out by yourself. When you send me your answers, I'm going to let you know how much you get so that you can see where you are when it comes to paper 1, and we're going to work from there. Okay? So I'm seeing some people saying that they're done. Anybody else still writing and need a minute? So I'm just going to zoom out so you can get an opportunity to copy it down. And so we see here, we understand what parallel vectors mean. Okay. All right. Equal vectors. Obviously, equal vectors is just what it says. Two vectors are equal if they, what it says here, vector E is equal to vector H if they have the same magnitude and direction. So obviously that means, what's another word for magnitude if anybody remembers? Anybody remember what magnitude means? Magnitude just means the same thing as size or length. How long the vector is. What's the size of the vector? What's the magnitude of the vector? All right. It follows that equal vectors are also parallel. Obviously, because one of the things you must take note is both of them must be going in the same direction if they are equal. So that means they have the same direction, same size. Everybody with me? And for those who are not here, we're going to look at how to find the size of a vector. So let's look at this next concept. And then from there, guess what? Guess what, guys? Once we finish collinear vectors, you know, we're done with vectors. All we're going to have to do is start going through examples. So that's what we're going to do today. So take a look. We literally only have 2 more pages to go to finish vectors. So let's finish the last topic, which is collinear vectors, and we are going to go straight into practicing some questions. All right. One of the things you have to realize is on a straight line, so I'm going to draw my straight line, it is possible to have several points. So I could have a point at the end. I could have a point at the other end, but it is possible to have a point somewhere else on the line. Everybody see that? So based on this diagram, how many points do we see on this one line here? How many points are you guys seeing? 3. All right. So in this case, because all 3 points, if we call this point A, point B, point C, all 3 points lie on the same line. So we need to be able to prove that. So what have we been able to prove so far? We are able to prove if 2 lines are parallel, and we know how to look for that. If one vector is a multiple of the other. So if we have x, y for one, the next one would be kx, ky. Agreed? So how do we determine if 3 points are collinear? It's literally the same thing. So let's take a look at what we have here. Notes, 2 vectors are collinear if one vector is a scalar multiple of the other. That ain't the same thing like if they're parallel. You realize it's the same thing? But the only difference is you have to use specific points though. So look at what they did. They said, if these 3 points on the same line, it means that my first line, because that's the next thing here. Let me go back up here. From this one long line, how many lines are there in all? That's a great question, actually. How many lines are there from this diagram? How many lines do you guys see? We have not done geometry yet. That's our next topic after vectors and matrices. So most people may not know, but I want everybody to take a guess. So I see one. Okay. Thank you, ladies, for trying. Anybody else want to make a guess? How many lines they think they see here? Okay, Chloe sees 2. I'll say 2. Okay, not bad. I would say 2 because of the points. Okay. Let me just explain a concept. What creates up a line? A line is a direct connection between 2 points. So if I have a point here and I have a point here and I connect those 2 points using a straight line, that's what we call a line. Everybody with me? So now You have 3 points. Let's look at the different lines we could get. This is one. Everybody see that one? Did you see that one before? Did you count that one? So that's one. Look at the next one. That's 2. But guess what? What happened to the original line straight from A to C? Line 3. Everybody see that? So look at it. Remember, you connect the 2 points. So the first line that we had was AB, because remember I was telling you about the representation. AB is a line because what 2 points create the line? AB. Next one, BC is a line. What creates BC? Point B and point C. But if I draw a line straight from A to C, that ain't a line as well. Boom. So excellent job for everybody who tried. That's the point, because you see, you have these aha, like, oh, moments when you try to figure it out on your own first. So that's something we need to keep in mind. So we have this first line, this second line, and this major line here. All right. So taking this information, my lovely people, let's look at what's happening here. For me to prove that 2 vectors are collinear, which 2 vectors we need to look at? We need to look at AB. Let me use red so we could see it, or yellow. We need to prove that AB and BC are what? Parallel. Everybody with me? And we know how to do so. We just need to prove that BC is a multiple of AB. And look at what they say here. Note that this is the same condition for parallel vectors. So for a line to be parallel or collinear, it must be parallel. So just prove if it's parallel or not, and you would know if it's collinear. So let's check it out. So let's go. Given points A, B, and C, use a vector method to prove the points are collinear. So what do they mean by that? So you got 2 ways you could do things in maths. You could use the formula way, or you could use the diagram. What I love about these notes is that they did what? They use both. So let's go. Anybody remember what we call any vector that starts at the origin? Anybody remember what we call those? So for those who are not here, anytime you plot a point, so let's look at point A, and you draw a line to the origin. And what is the origin? The origin is where X is 0 and Y is 0. That's the middle of the graph. So if you have a graph, right here in the center is what we call the origin. Everybody with me? And at this point, what is X? X is 0 and Y is 0. All right. So for those who never heard that terminology before, you know. So we covered this in the previous class. I'm not going to get into it deeply. Again, watch the videos. Watch the videos. So let's go. We want to prove that all 3 points are on the same line. So let's plot the points. That's what they did here. It's just a quick sketch. But this is what you really need to learn and understand. We need to prove that BC, let's look at what BC is. BC and AP are parallel. So we need to find 2 displacement vectors. You realize they gave us the points. So for those who do not know, if somebody give you a point, what is X in this example? And this is something you should know already based on what we did in graphs. If you got a point -2, 1, which one is the X? Exactly. And which one is the Y? Very good. So we could represent A as a vector starting from the origin. So we call it a position vector. And what would our position vector be? All we're going to do is take these points and write it in the vector form. So who always comes first? X always come to the top and Y always come to the bottom. Everybody with me so far? So let's go. OA is what we would call the position vector in this case. What would OA be? OA would be -2, 1. Everybody following me? So how do we change B to a vector? What would B be as a vector? It would become OB, and we know that 2 is the X and 3 is the Y. So 2 to the top, 3 to the bottom. Boom. Everybody with me still? Next one, OC. What is OC? OC is equal to 8, 6. Which one to the top? The X to the top, so that's 8. And what's to the bottom? 6. Boom. So as you realize, all we did was move this point from horizontal representation to what? Vertical representation. That's how you change a point to a position vector. And if you don't know what position vector is, it's when a vector is created by moving from the origin to the point. So as you see here, look at what's happening. We move from the origin to A. Everybody see that? The origin to B and the origin to C. Talk to me. Especially those who missed class. So this would be new for you. But do you kind of understand the whole concept of moving from the origin to the points and how you represent each vector? So all you did was take this in this form and change it to that. You took 2, 3 horizontal form, you change it to that. You took 8, 6, and you change it to that. That's literally it. All right. So now that we have that, we have our 3 vectors. What do we do? Now this one, I don't like this one. You know why I don't like this one? Anybody could tell me why this one is a little bit different? Don't study none of this up here yet. We're going to get through this. I want you to focus here. So you realize they found BC. This was BC. And this is AB. Is the factor K a whole number? Look at what the factor is in this example. You realize it's 1.5. Everybody tell me if you see that's what K is here. So this one ain't as obvious. You can't really tell. So guess what you have to do? Everybody realize that? So it's not like 6 and 12 where you could just look at it and see. So what do you do when you see an example that doesn't look obvious? How do you check it? Guess what you're going to do for me, guys? You're going to divide this X by this X. Everybody take out your calculator and put 6 divided by 4. Tell me how much you get. Everybody get 1.5? Very good. Now, do the same thing with the Y's. So say 3 divided by 2. 1.5 again. And so you realize these 2 lines are parallel because what do you realize? Both numbers use 1.5 as K. So the part I want you to pay attention to is what? That in this case, they are parallel, but it is not as obvious. Everybody see that? And how do you check? Divide these 2 numbers by each other and see if the answer you get for both the X and the Y is the same. If they are the same, that is your K. Everybody following me? Let's try another one. So I'm going to do one on this side and you're going to tell me if it is parallel or not. So let's try another one. So I'm going to give you 2. I'm going to give you M and I'm going to give you P. So what you're going to do is determine, it's not going to be an obvious one, obviously, but you're going to tell me if it is parallel or not. So let's start off with our M. I'm going to give my M a 2 and 3, and my P, I'm going to put 5 here. I'm going to put a 7.5 here. So everybody tell me what is K. Everybody tell me what K is. Because remember, that's the most important part. We must state what K is. So let's go. So I have some different answers. So guys, which one do you dividing by? You are dividing the wrong numbers. Remember which one is you're supposed to divide by which? You ain't supposed to divide the bigger number by the smaller number. Let's look at what we did before. What did we divide? The bigger number by the smaller number, and not the smaller number by the bigger number. Everybody see that? Remember, one is a multiple of the other. So you have to divide the bigger number by the smaller number. So try it again. Excellent. So when you say 5 divided by 2, what do you get? You get 2.5. And when you get 7.5 divided by 3, what do you get? 2.5. And so K is equal to 2.5. How do we back check, guys? How do we back check? If we multiply M by K, what should we get back? We're supposed to get back 5 and 7.5. So back check it. 2 times 2.5, tell me if you get 5. Talk to me, talk to me, talk to me. In maths, we always have a way of back checking. So you get 5, so you know that's right. Okay, which part making you lost? So let me use another example where it's easy. So I like to use different examples so we could compare. So let's use a different M. So let's use an M, same 2, 3, but instead, let's use K is equal to 4, 6. How do you find K? Let me see. Let's do this easy one first. Let me don't use K, let me use N. Let's say I gave you 6 and 9. Everybody, let's do this one first. Let's see. How do we find K here? Don't we say 6 divided by 2? So what do we get when we say 6 divided by 2? So let's go. 6 divided by 2, 3. So what we going to say now? We're going to say what? 9 divided by 3 is what? 3. Everybody see that? So Gwen, you see that? So what is our K in this example? K is what? 3. Remember, what is the point of finding K? Remember, N is equal to 3M. Right or wrong? Then what we're trying to prove? That one is a multiple of the other. And let's back check it to see if that's correct. Let's go. What is N? N is 6, 9. And we multiplying M by 3. So what is 3M? 2, 3. So let's check it. 3 times 2 is 6. That's correct. 3 times 3 is 9. That's correct. So all I was doing above here was back checking to make sure when I multiply by K, I get back my N. You see what we're doing, Gwen? So let's go back up. Let's go back up. The only difference is here that K is not a whole number. And let's be real. See, if CX give you a whole number example, they're going to be very generous. You know, they're going to always give you the more challenging option. So we know how to find our K. That's what we did here. So all I am trying to do is prove what? That P, which is the bigger one, is equal to K times M. You see that? So if I multiply 2.5 by M, I must get back 5 and I must get back 7.5. So that's all we were trying to do. So let's check it out. So let's put, so we know P is equal to KM. What is P? P was 5 and 7.5. What is K? K is 2.5. What is M? M is 2, 3. So let's go. When I multiply 2.5 by 2, everybody, did we get back 5? Yep. When I multiply 2.5 by 3, did I get 7.5? Yes. So guess what? Once you could prove this, you would put what? Therefore, the points, whatever points they ask you for, are what? Collinear. That's it. See what I'm trying to say now? So let's look at the actual example. So that's it. So you see here, BC is equal to KAB. The only difference here is that they use the vector notation rather than a single letter. But it's the same thing where they give you K and you just had to prove that. You see, when you work out this times this, you get 6. When you work out 1.5 times 2, you get 3. Everybody see that? Don't worry, as we go along, we're going to do more examples for you to understand. All right, so let's get back to this part now that I want us to focus on. If we look at our equation, let's erase all of this. This is the most important part now. Now that y'all understand how to prove if they're collinear or parallel, let's see how do we get the stuff that we need to prove it. Based on the question, did they give us BC and AB for us to use to do this? What y'all realize? Did they give us A, B, and BC? Yes or no? Let's look at the question. Everybody tell me what you think. Did they give us the vectors already? Let me erase all of this here. Look at the question. And this is a serious question I need everybody to try answer. Based on the question, did they give us the vectors? Read it and tell me what you think. Read the sentence. They literally say given something. Is there any vectors there? Did they give us AB? Did they give us BC? Guys, no, they did not. Look at what they gave us. They gave us point A. They gave us point B. They gave us point C. What we did was find the position vectors. But watch the position vectors we got. We were given OA, we were given OB, we were given OC. Everybody with me now? And understand what I was really asking? For us to go down here and do the proof, you realize what we use for the proof? What did we use for the proof? We needed to find the lines, which is what we spoke about before. But you have to realize, look at what the question give you and look at what you need. We need AB and we need BC. But the question did not give us that. The question give us points. And as we already know, we could change a point to a position vector. But none of these position vectors is A, B, and BC. Everybody with me now? That's why I need to make sure if you're here with me now and understand what I'm trying to make you see. All right. So based on what we did last class, because what I taught last class is how to find AB and BC using the position vectors. So this is what I'm going to reteach quickly for those who are not here. So let me know if you're ready. This is a quick revision. When you guys look at the video, you're going to see the notes. You're going to see and understand a lot better, obviously, because that was the focus. So I'm just going to try to go through it as easy as I can. Okay, check this out. Let's look at the picture. If you got point A, look at the vector. So I'm going to zoom in. For now, you got to pretend like this black line not here. Agree or disagree? Because if we look at what we were given, they didn't give us this line. They didn't give us the vectors. Agree or disagree? So we got to pretend for now that we have this line here. So the yellow line ain't there. All we have is these 3 red lines. They gave us point A. They gave us point B. They gave us point C. And we could create vector position vectors by just connecting it to the origin. So everybody with me so far? So looking at this, based on what we learned today, we want to go from A to B using the lines that we do have. So if you start off at A, what do you realize you got to do? You ain't got to go back to O and then from O, go to B. Talk to me. Remember the yellow line here don't exist and no line there at all. So we got to use the lines that we have. And the lines that we have is just the vectors that going from the origin to the points. Everybody see that? What do I call? Okay, everybody see that? So what do I need? I need to go from A, O, plus, then once I get back to O, I'm going to go from O to B, which is what? OB. Anybody seeing this magic here? And what I love about vectors is like you're walking on a pathway. Look at where we started. We can't just jump from A. You can't just jump from here to here. You got to follow the paths. So look at the pathway that we created. We started off at A. We went to O. And if you look at it, O is also by OB. You could go from O to B. Everybody seeing that? So for you to add two vectors, they must have a point in common. This is what you call the triangular law. So all those who were not here, everybody kind of see what I'm trying to show you by following the paths. Let me go again. We want to go from A to B. So we got to follow the vector. We got to go from A to O first, and then from O to B. That's how we end up with AO plus OB. I'm not moving any further until y'all let me know how y'all feeling about what I just did just now. Even if you understand every single thing, do you understand how we move from A to B using the path? Okay, now check this out. Let's look at what we do have from this. Anybody realizing something? We got OB and it. What is OB? OB is what? OB is simply just 2, 3. Everybody with me? So you're right, 2, 3. But let me ask y'all this question. Do I have AO? I don't have AO, but what do I have though that could help me get AO? Me got OA. And look at this. Y'all remember when we did this? If forward movement is A, what would be the backward movement? What is the backward movement? A negative A. So if you got the forward movement, which is positive OA, how do you find AO? A and just be negative OA. Hello? Y'all can hear me now? I hear talk. Hey, this thing is something else. I hear talking. What was the last thing I hear? Cause me done gone, you know? Me done gone. What was the last thing y'all heard? My goodness. So let me start all over. Let's start all over again. Let's start all over again. So let's back check. Everybody understand where I get OB from? We got OB from the position vector. So everybody, let's take it step by step. And I need everybody to respond, especially the students who are not here for the class where I taught vectors. So let me see who we got here today. So I see Alicia, Cloris, Ash, you were not here as well. Trev, I'm not sure. Natalia, y'all talk to me through this, okay? Just keep me updated with how you are so I could know what to focus or what to repeat. So let's go back again. I'm just going to start back from scratch. So let's go. What is the point of all of this? We need to find two things. What are the two things we need to find? We need to figure out what is the vector from A to B and what's the vector from B to C. Everybody with me so far? But based on what we realized, the question didn't give us those vectors. So we have to figure out how to find it. Based on what we did last class, we could calculate those vectors using what we have here. So let's keep in mind, if you look at the diagram, if I want to go from A to B, let me zoom in again. I have to go from A back to O and from O back to B. When we look at what is happening, we could write an equation that is something that we did last class, which would be, what is the equation? A, let me use black. And let me just erase all these things that could become distractive. Because I don't want y'all to lose sight of what we're trying to focus on. So everything here, I'm just going to erase because we don't need none of this anymore because we understand how we got these position vectors. Right? So let's go. I want A, B. I want to go from A to B. What is the path that I need to take to get to A to B? You always start off where? At A, in it. So you're going to go from A to O. Everybody agree with that? So you go from A to O. Then you go from O to B. So this is the part I need everybody to confirm that they understand. How do we know we could add these two vectors? I could go from A to B comfortably because I have a common point that I could jump from one to the other. So I need everybody to confirm if they understand what's going on here. Why are we doing what we're doing right now? Okay. All right. So let's go. Let's look at the vectors we do have. We got three position vectors. We got OA, we got OB, and we got OC. But what do we realize? AO is going in the opposite direction of what? OA. Everybody get that point too? And what did we learn earlier and last class? If going forward is A, going backwards going to be what? Negative A. So let's go. If I want AO, I have to write what? Negative OA, because OA is what we actually do have. So we just got to make it negative. Everybody following me so far? Do we need to change OB? We don't need to change OB because guess what? We already have OB. So we just write back OB. So everybody confirm if you're with me again. Step 2. And I just want to tell y'all something, right? You wouldn't believe 95% of the question is just like this. So we're going to see a lot of questions like this and we're going to keep practicing and practicing and practicing. So let's go. All we need to do now is substitute. So let's go. We're going to substitute. We put back the negative. What is OA? Let's look at the equation here. OA is what? Open bracket, -2 and +1. What does that mean? I have to multiply the negative by these two numbers. Everybody see that? Plus, what is OB? OB is 2, 3. Everybody with me so far? So let's go. Based on what we've learned, what have we learned about negative numbers? If I multiply negative to -2, what am I going to get? Everybody, let's go. Because this is quick revisions for integers as well. So negative times -2 can give me what? A negative and a negative can always give you what? A positive. Remember, A have no number, so the only thing that can change is the sign. Everybody see that? So it's just going to become a +2. But what going to happen to the 1? What is the 1 going to be changed to? So instead of +1, if I multiply 1 by a negative sign, it's just going to become -1. And that's it. Now, even if you weren't here, which two numbers you think you're going to add? It's almost like you're adding just the 2 x's and you're adding the 2 y's. So for me, what I like to do is just put it in one big bracket. So I would put 2 plus 2, -1 plus 3. Everybody with me so far? Y'all still with me? Okay, so let's go. What's my final answer? What's my final answer? It's going to be 4, obviously. And -1 plus 3 is what? positive 2. Excellent. And guess what? That is what AB is. Look, we just calculate what AB is. So AB, so we put therefore, AB is equal to 4, 2. Everybody with me so far? Look at that. So we just did the first part here together. We found AB. So tick off that. So how y'all feel? Y'all ready to try the next one and see if we could get the next one as well? So we found AB. What's the next line we got to find to make sure that they're collinear? So we found AB. So what we need to find next? Anybody remember what we got to find? Exactly. Very good. We need to find BC. So let's go. We're going to break it down again. So based on what we're looking for, let's go. We're going to write BC. Anybody think they could figure out what the formula for BC is? What do you think BC going to end up being? It's going to end up being BO plus what? OC. Anybody starting to pick up the pattern? The two middle terms is the same and the end terms, beginning and ending. Anybody picking it up? That's the point of this, you know, for you to understand the pattern, to understand what it is you're doing. And this is called, again, the triangular vectors law. How you spell triangle, guys? My mothers. I know how to spell it here, but right now my mind just like tired. So it's the thank you, triangle vector law. And you understand why it's a triangle? Let me just zoom in to make sure y'all see why it's a triangle. Let's look at the picture. What shape? Let me zoom in some more. So let me just erase this ugly black line here. So follow me. When I do my vector thing, look at it. I go straight from here to here. And I go straight from here to here. It allows me to go from what? From A to B. So once you calculate this properly, you see the shape that you form. Everybody see that? Everybody see why it's called a triangular law? Because once you follow the pathway and then you connect the 2 points, that's how you create the direct line, by making the triangle. That's the way it's called the triangular law. So always remember, you cannot just jump from one letter to the next. You have to follow the triangular law, which means you go back to the baseline, which is O, then you go from O to the letter, and then after you travel that line, you could do the shortcut. And literally, that is the biggest concept in vectors. That is the biggest thing you're going to be doing in vectors. It always comes. So let's go, my awesome people. Which one do we have and which one do we don't have? So let's start off with what we have. Out of the 2 vectors, which one do we have already without it needed to be changed? Remember, these are what we have over here. Look at what we have over here. Look at the options over here. Remember, we got OA, OB, and OC. So let me go back over again. Which one do we have that don't need changing? Anybody seen it? OC. That ain't true. Look at OC. We ain't got OC already. Remember what we were given? We were given OA, OB, and OC. We have OC just as how it's supposed to be, so we need to change it. Everybody with me? Did they give us BO? Nope. Look at it. Did they give me BO? So let me erase all of this. So what do we do to find BO? They gave us OB. So if we want to go the opposite direction, what do we do again? We apply what? The negative sign. So we apply the negative sign to what they gave us, which was OB. So we have negative OB. Everybody realize the steps is exactly the same thing? Everybody with me? So what is our next step now? Our next step is to substitute what is OB and what is OC. So let's go. So I'm going to use black again. So I'm going to put back my negative sign. What is OB? OB is what? 2, 3 plus OC, which is what? 86. So my question to everybody is, what is going to be my value for the first set of vectors? So instead of 2, 3, what will I end up with? No, just apply the negative sign to the numbers. Let's go. So instead of positive 2 and positive 3, when we multiply by this negative sign, or we apply the negative sign to these two numbers, what two set of numbers we can get instead? We're going to get negative 2. If we make a positive number negative, it's going to just be negative 2. Everybody see that? Let me know if you're following, because only a few people answering me directly. What about everybody else? Look at this. We just applying the negative sign to both numbers. That's all. So negative 2. And what will be the second number? Negative 3. Excellent. Excellent. And you know, people just think vectors hard. Be honest, based on what y'all see so far, for the one class you've attended so far, or the two, is it extremely difficult? To me, algebra way harder than this. Algebra is pretty hard. Vector is pretty easy. So let's go. What is the next step? To add this equally. To be honest, you can add it separately. But for me, you know why I want y'all to join it up to just make it easier for you. So you know it's negative 2 plus 8. And the reason is, suppose you had a negative sign here. It makes it easier to see. You see what I mean? Clashing signs. So always put them together. So we got negative 2 plus 8. I don't know where this red come from. Then we got negative 3 plus 6. I just want my final answer now. Let's go. What's my final answer, peoples? Excellent. 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 Very good. So we have our two new lines. So we got BC. Don't forget your arrows, because remember, if you just put BC by itself, you know that just means a regular line. That's not a vector. So always put your arrows. So BC is equal to 6, 3. Guess what, guys? That's it. That's it. So we're going to just look at some examples now, and we are going to end today's class. And on Thursday, I'm literally just bringing all past paper questions so we can start looking through past paper questions. But before we start looking at some examples, how do you feel about vectors at the moment? Out of 10, in terms of what you've been able to follow. So not what you're able to remember, but what you're able to follow and understand. Talk to me, talk to me. To be very honest with you, I tell my students so too. I was like, vectors easy. I was and I'm glad I did it now, because I think I could knock it out as fast as possible so we could move on to something a little bit more. Matrices is easy as well, but it just have a lot of working. You have a lot of calculations. That's it. But matrices is also pretty easy. All right, so let's go. Let's go, let's go, let's go, let's go. So we have an example we're going to go through. And don't forget, print this document, please. Use it to revise. Take a scrap paper, write down the questions, and see if you can work out these questions on your own. So this is a CXC question, to be honest. And so we're going to realize something is a little bit different or more complicated. So let's go. They say 2 points A and B have position vectors -2, 5. OB is 4, 2. Where O is the origin. The point G lies on a line AB such that AG, this done kind of confusing already, buddy. Let me take this again. Whew. Let's go again. First thing first, let's break it up. I'm going to separate this first part here. So let me see if everybody with me so far on this part. You realize, no, they didn't give you the points. But suppose I was to ask you about point A. How would you be able to give me point A? All you need to do is write it in the horizontal version. Everybody with me? So if they give you the position vector OA, point A, if OA is -2, 5, what is point A? What's the coordinates of point A? -2, 5. Everybody with me? Remember that? We spoke about it before. Similarly, what would be point B, guys? If OB is 4, 2, what is point B? What is the coordinates of point B? Everybody take a try. And don't forget, if you don't put the brackets, it's not coordinates. So that's correct, Cloris. It is 4, 2. You just need to make sure you always put your brackets. Last one, if they give you a position vector OC as, this is just a random one. -3, 4. What is point C? Everybody. Only Cloris answered the question before. Everybody needs to answer this one. Excellent. Excellent. It's just going to be -3, 4. Keeping in mind that your X value is always to the top, your Y value is always to the bottom. X value to the top, Y value to the bottom. X always come first, Y always come next. All right, so that's that. Now here's the trick about this. The point of this is to draw. Yeah, realize when you draw it, it makes it a lot easier to follow. So this example, the purpose of it is for you to draw and visualize some stuff. But I'm wondering if I should go and come back to this example. No, I will not. We're going to look at it. So let's go. They gave us these 2 points so far. What 2 points they gave us, guys? They gave us a point A and a point B. Everybody agree? So I am going to sketch this graph so y'all could understand how to build up your graph from scratch. So you realize when we didn't really number anything, because guess what? When you're doing a sketch, it's just for you to make sure you understand how it looks so you know what to do, and not about, oh, this is 1, this is 2, this is 3, this is 4. Everybody with me? So it's just an estimation when it comes to plotting. So let's go. First thing we're going to do, we're going to need our X and Y axis. And if we see what type of numbers we have, we know we have a negative X and a positive X and both positive Y's. So we know we're dealing with both sides of the upper section, because the upper section is where we have what? Positive Y's. But this side is what? Positive X. And this side is negative X. Everybody with me so far on why I chose this graph and not a graph that look like this, or not a graph that look like the entire 4? Remember, it's all about working smart. So these are the things I want to make sure I highlight. Okay, so let's go. They gave us these 2 points, -2, 5. So I'm just gonna estimate where would I find -2, 5. So I would find -2 somewhere about here, and I will go up 5. So let's say I call this 5, and I'm gonna call this my A, and my A is -2 and 5. Everybody see that? Maybe I should have moved this point a little up. All right, next one, B. B is 4, 2. So if this is 2, -2, 4 gonna be a little bit more over. And and if up here is 5, where would I find a 2? I would find a 2 like somewhere here in it. Like right here. I could find a 2 here. Looking good in it. If 5 is up here, 2 must be here. So you put your B. 4, 2. All right, so everybody, let me know if this is okay for you, if you understand how I did that quick sketch, because that's important. All right. Now, do we ever go and just connect those 2 lines directly? No, we do not. What must we do? We must draw our position vectors. That means we connect the point to what? My mother's here. We connect the point to the origin. Very good. So far, we're looking good. Everybody with me? Boom. Boom. Everybody talk to me, talk to me. Everybody following how we get this so far? All right. What I realized they did, they cut down the y-axis so it don't get in the way and confuse you when you draw the line straight over. Okay? So let's go. Another thing that they gave us, so let's read through. So now that we have the first part, all we did was literally just draw this part here. So everything here we done accounted for. So let's continue. The next part gives us another point G. And look at what it tells us. G lies on the line AB. So what y'all realize here, unlike other examples, what must we have already drawn? We must draw what? Let me see if we're thinking. What must I draw now? Since to find G, I need the line AB. Everybody see that? I can't draw the point because the point is on the line AB. So we need to do what? Draw the line AB. Boom. Everybody see that? Everybody understand how you build your diagram? It's about using your logical sense. And obviously, I can't put on G without AB. So you know you do AB first. So let's go now. The point G lies on AB such that, so this is going to explain where AG is. What's going on here? AG, that means if I put on a point, let's say I said G is here. Everybody realize that's how we find AG? So they're describing the distance from A to G. Everybody with me? With that part there? So let's erase it. It tells us that AG is a third of AB. Let me just use a half. If it was a half, that would be easy to find in it, because what we would have done with AB, we would have just cut AB somewhere like this, and this we know the middle point is G. Agree or disagree? If it was a half, but it's not a half. What is it? It's a third. So you just gotta estimate it. If I was to bust this up in 3, let me see. If I was to bust this up in 3, that looking like it, isn't it? Everybody see that? That looking like it, isn't? So just to understand that that's how we get the third, that means my G gonna look like it's somewhere here. So I label that G. Boom. Talk to me, everybody. How you feeling? Okay. So guess what the next question is? The question says, express in the form XY, and you know what that means, right? The vertex form, the vector form, where X to the top, Y at the bottom. What's the first thing they ask us to find? Anybody see? They need us to find. So the first question is, find AB in that form. And we should be able to handle a yes or no. So we need to find AB. And based on what we learned just now, what we need to do, we need to use the triangular law in it. Anybody willing to volunteer how to find AB again? We did it before. It's the same exact formula. So what do we need to find AB? We need AO, excellent. Very good. Plus what? OB. Very good. Hoorah. Hey, if I was in class with me, I'd have fling everybody $5. Big man thing. Everybody got $5 there. Very good, man. Very good. Send on, definitely. I'm very proud. Very, very proud. So let's go. Based on what they give us now, let's go back to the original question. We on the money. We on the money. We passing max. Let's go. Based on the question now, my good people, what did they give us already? They gave us OA and they give us OB. Don't we have everything we need? Because we don't know how to change OA to AO. And they don't give us OB direct. So come on, give me again goosebumps and all. Let me keep the momentum going. What should I write for AO? It should be what? Negative what? OA. Everybody agree with me so far? Plus OB. So what am I going to find the negative of? I'm going to find the negative of OA. And what is OA? -2 and +5. And then I'm going to add on. You see how the Babylon system ain't want us win? We on our right track. It's sticking. Anyway, there we go. Rebuking in the name of Jesus. So there we go. Plus OB. And what is OB? 4, 2. So now that we have everything we need to find AB, let's go, my peoples. what is the first thing going to change into? So instead of -2 and 5, what will I have happening here? What's my new vector? What is AO? Very good. Remember, the negative and the negative going to cancel each other. So it's going to become +2. And when you add the negative to the 5, it's going to become -5. Very good. I'm just going to skip the part and just add one time, right? So we're going to add the 4 and then we're going to add the 2. So give me my final answer. So AB is equal to what? Excellent. Excellent. 6. Would it be +3 though? Remember, this the answer takes the sign of the bigger number. So you have the right digit, but instead of +3, it's going to be what? -3. Let's look over here to the side. I hope y'all wasn't watching over here, innit? Boom. Look at that. Look at what we did. Everybody with me? That means you're focused. Come on, everybody talk to me. How you feeling? How you feeling? How you feeling? You see, you were able to work it out on your own? Very good. Now, guess what? This is the part that CXC descent. They're going to ask you to find AG. So I'm just going to use the example here to explain why. What piece of information going to explain to us how to find AG? Then give us the equation. Look, the equation right here. Let me zoom up in it there. Let me zoom up there. Look at this. Then tell us how to find AG. To find AG, we must do what? Find a third of AB. Agree or disagree? No. When you're finding a third of something, what is finding a third the same thing as? I explained a lot on Sunday. So people who were here on Sunday, was anybody here on Sunday? So let me just go to the site to just teach you something quick. This is going to help you with algebra. If somebody say find the half of something or multiply by a half, do you know it means the same thing as dividing by 2? The number by 2? Let's check it out. Let's multiply 4 times a half. 4 is the same thing as what? 4/1, isn't it? So we're testing out the theory to see if it's true. Everybody with me so far? What do you do when you're multiplying 2 fractions? You cancel, right? So 2 into itself goes once, 2 into 4 goes 2 times. So what's your answer? 2 times 1 is 2 over 1 times 1 is 1. And anything over 1 is what? Itself. Everybody remember that? But look at this now. 4 divided by 2 is just what? 2. So multiplying by a half is the same thing as doing what? Dividing by 2. So based on that, what would be the equivalent of multiplying by a third? Multiplying by a third is the same thing as doing what? Exactly. Bingo. Dividing by 3. Everybody see that? This could save you a lot of energy in the future. And I'm going to show you why this is useful. So let's go. Let's go, let's go, let's go. So we're just going to use this working out here. Let's go. So we see here that, what do we see? We see here that AG is a third of AB. So I'm going to write that part out so we can see. You can't just jump into it. You have to write it out. So let's go. That's what they gave us. They told us that AG is equal to a third of AB. Let me ask you a question. We ain't just calculate what AB is. So let's substitute. Let's substitute. We're finding a third of what? 6 - 3. And look how beautiful these numbers are. Look how beautiful these numbers are. So guess what this really means? So let me break it down for you. This really means 6 divided by 3 and -3 divided by 3. Let me highlight it in red. Each number, whatever happening on the outside, you have to do it to both numbers. That's something you need to realize as well. Everybody see that? You have to do to both numbers. So you're saying 6 divided by 3 And then you're going to say -3 divided by 3. Everybody with me? So this is a combination of revision of algebra. So what is our final answer then, my people? 6 divided by 3 is what? 2. And -3 divided by 3 is -1. So guess what we just did? We found AG. Boom shakalaka. Let's go back to see if that's correct. Let's go back and see if that's correct. 2 -1. Boom. Boom, just like that. The only thing you realize they didn't show you how to work it out. That's why I did it on the side. Because notes like this, they're going to just give you the answer. But everybody should understand how they get this. They just divide by 3. Divide by 3. Everybody with me? Just like that, easy. Questions like this just come a lot. They can always say, oh, this next random point is halfway. This next random point is a third way. That's all you got to do, literally. Once you find out the base, you're good to go. Everybody with me? Let me know if you're with me. Let's go. Next question. Now, this is tricky. This is tricky. No, it ain't really tricky, to be very honest with you. Let me stop playing. Here, they want us to find out the position vector OG. But how do we find OG? Remember, OG is like we want to find the point of G. You know that, right? If you find OG, that means the point of G is 0, 4. Everybody see why it's important to know what OG is? Because the truth is, whenever they ask you to find OG, it's because they want you to find point G. Let me know if you understand that. All right. So check this out. Anybody recognize what it did here? What rule, what law did they use here? What law did they use, guys? They're saying the triangular law, but they just switch it up. And look at how they use it. So we're going to take this opportunity to learn something here. How you can manipulate the triangular law to find anything that you want. So look at that. Based on what we just find, we got a few things. We have OA. That ain't true. We got OA. And what did we just find? We just find AG. Can't we use this to find OG? So look at it. OG. And what in the middle? In the middle ain't the two matching letters. Anybody see the formula there? Anybody see how you just go about finding any vector that you want? How do you combine two separate vectors to create the vector that you want? So we want to create OG. So we want to go from O to G. How do we do that? We know that there's a way for us to get from O to A, and we know how to get from A to G. Right or wrong? So I'm going to pause right here. Please don't tell me y'all ain't hearing me again. Okay, I see Gwen answering. So that means y'all can hear me. So that's 2 rights. That's 3 rights. Anybody else? Let's go, let's go, let's go, let's go. And I'm going to show you another trick on this side. We're going to do a little drill to just solidify this concept. So based on what I've said, if you look at all the vectors that you have, we want OG, so we could create OG by using OA. You always start off with your original point. The starting point that you want should always be what started off. And then the ending point should always be where you want to end with. And what should be in the middle? A common point. All right, so let's go. We just follow the formula and all they did was substitute. So we know what OA is from the beginning. Well, not the beginning, but you know, we found OA before. Look, we found OA here. OA here. So we don't find OA. So they just use it and they plug it back in here. Everybody see that? And then they used AG, and AG is what we just found. And all they did was add it. And once they add it, they found OG. So let's watch something down here now. Quick drill. I'm going to give you a set of vectors and you're going to tell me how to find which ones you will combine to find a few. So I'm going to give you OP. I'm going to give you OQ. I'm going to give you OM. So let me know if you are ready to try this quick drill. So let me know if you're ready. Say ready, ready. We almost done. We almost done. You said I'm gonna put on some soca now to lift the spirit. This is one of my favorite songs. So we're gonna go through this question. We're gonna practice this skill because it is a skill, and then we're gonna look at the last example and end class. All right. So we got OP, we got OQ, and we got OM. I need you to tell me what is the formula to find PQ. What do you do to find PQ? So type it in the chat. Let's go. Close. Everybody, what happened? Let's go. You can't learn if you don't make mistakes. So making mistakes is important in learning math. So let me see what y'all working with. So Natalia, you got the right elements, but you need to put it in the right order. Y'all want me to do this first one for you guys and then you could try another one? Talk to me. Okay, let's go. Which two that we need? We need P and Q, right? If you want P and Q, which two you think you could combine together to get P and Q? Wouldn't you need OP and OQ? That's the first thing. So confirm if you see it. Good. Now, in this example, because I want to add these two, what should my first letter be? Can I use OP or should it be PO? That's the thing you're supposed to be asking yourself. Exactly. So it's going to be PO instead. May I really care about the calculation part? What I'm caring about is the equation part. So let's go. PO. So what should I add to get to Q? We just says between these two. So we don't use OP already. We just switch it. So what do I add to get to Q? It would be OQ. Everybody see that? And look at how the movement is. You move from P to O. And once you're at O, you're at O. And then you're going to move from O to Q. Everybody see that? What is most important? That these two numbers in here match. And the beginning point is the beginning point that you want. And the ending point is the ending point that you want. Everybody seeing it now? A little better? Let's try another one together. That's the purpose of this session, for us to solidify this skill. So let's go. I want PM. Let's go. Take a try. Okay then. But look at what in front. When you have it right, but you mix it up. Look at what letter come first and look at what letter come last. So just fix it quick for me. Excellent, everybody. Always use capital letters, okay? No common letters. So let me go. Because we starting off with P, P must be in front. So we need to switch OP to PO, which is correct. Plus, the next thing that we use has to start off with O. So, because we want to go to M, we're going to use what? OM. Guess what? That's it. Everybody with me? Let's try another one. Suppose I want QM. Let's go. Next one, QM. I'm watching. Excellent job, guys. Excellent job. QO, very good. Plus OM, very good. Very good. How y'all feeling now? A little better? Because I can take it up a next notch, eh? Very good. I'm very good for not giving up. Let's try a harder one now. Suppose I want, let me see. Feel nice. Oh, nice. Oh, like it nice. All right, I'm gonna do something here. Find OA. I kind of make it easy for you too. If you ain't see it, may know what else to do. The answer kind of there already. What's the formula to find OA? You can't tell nobody. This is between you and me. There we go, guys. If I want OA, but guess what? Any AO here, no OA here. You have to use only what is here. You could only choose from 1, 2, 3, 4. So out of these 4, which 2 can I combine to make OA? Ha! That's right. That is right. Everybody see why that's correct? Look at it. It's going to be, you want to start off with O, so it must be one of them that start off with an O. And what connects O to A? M. So you're going to have OM. Let me just use a different color so you could stand out. If you use OM, right? Check this out. OM plus MA. Everybody seen it now? For those who didn't see it at all, you realize what happening in here? It matching, so it cancels out and it gives you OA. Everybody with me now? A little better? Let's try another one. I'm going to add on one more. But you see it now? Okay, let's try one more. I'm going to give you QR. So find OR for me, please. Sorry, this is QR, not OR. This is QR. So how do you find OR? We cooking on gas. We cooking on gas. We move from off of the cold pots, them guys. We cooking on gas. That's what we're talking about. Excellent job. So it's OQ plus QR. Very good. You see, once you master this skill, there is no vector you cannot find. Everybody understand what I'm saying? Excellent job. Excellent job. So guess what? We are done with vectors. We are done with vectors. Right on time as well. So what we're going to do, we're going to just look at one more question. Let me see how much we got. Just these 2 last pages, but we're not going to do all of this right now. So we're just going to focus on this class activity where the answers are to the back. So for those who don't know, let me just pause the music. So guess what your personal job is? Your personal job is to try these questions on your own. When you first try them, it's going to be a struggle, but it's all about trying, okay? When you try them, the answers to all of them is in the back here. Everybody with me? Talk to me, talk to me. So these are some activities that obviously we're not going to get through all of them. And this is where your individual working. You want me to send you again? No problem. Just send me a WhatsApp as soon as class finish and I'll send it to you. I really do recommend you guys printing these documents because it's going to help a lot. I'm currently in the works of like editing them and adding more stuff. So, but for now, we got to make use of these ones that we have. So let's answer, let's do class activity 1. And then let me see. The rest of them pretty easy. So you see finding A and B, you use the formula. And then what you realize is that these here using 2 different notations. They use in the double letter notation and then the common letter donation. This is very important actually. Let's do this question right now, actually. Let's do this right now. Because this is literally a CXC question. I was watching some papers and I saw one just like this. So before we continue, let me know how y'all are feeling. Y'all up for just going through these examples or y'all want to end? Keeping in mind, the more we do, the more space and time we have for practicing. So we could end now and you guys could take a look at them after on your own, or we could run through at least 2 of them and then you guys look at the rest on your own. That sounds okay? All right, so let's go. We're picking up on momentum. So let's look at this first question here. All right, so let's look at what they gave us. They gave us the position vectors already. Everybody with me? So let's go. They gave us OA, they gave us OB, and they gave us OC. So let's look at the first question that they're asking us for. The first question asks, express in the form AB, BA, and BC. That's baby stuff. So there we go. We're going to run through this quickly. We want 2 things. We want AB and BC. So let's do AB first. Not AB, BA, sorry. BA. Anybody want to help me with the formula for BA based on what we just did? If we want BA, what we should start off with? We should start off with what? BO plus OA. Agree or disagree? So we're going to run through it, but I just need you to let me know if you agree and you understand how I got that. Agreed? Excellent. So let's look at the diagram. They gave us OB, so we know if we need BO, we need to find the negative of OB, which is the negative of 3, 4. I'm just going to skip all the extra stuff that we were doing before because we understand what's happening. And then we have OA, and we just add it as is, 6, 2. Everybody with me so far? So we're going to have some new numbers. We're going to have -3 and -4 plus 6, 2. Somebody give me my answer quick there while I write it up. So you know it's -3 plus 6. -4 plus 2. What's our answer for BA? So BA is equal to what? +3, -2. Everybody with me? Once you confirm, we're going to keep it moving. So just confirm with me if you got it. Excellent. So let's do what we're doing next. BC. So based on what we have here, I know I'm going to need OB and OC. So if we want BC, we know what we're doing. We're finding BO plus OC. So there we go. BO is again, we need to go through all that because we know BO, we found it before. So that's -3, -4 plus OC. What is OC? OC is 12, -2. 12, -2. So anybody want to help me out quickly with what the answers are? And you realize why I keep asking that, because it's about being able to move fast. That's how you get your exam and finish everything. moving at a steady pace. So what is negative 3 plus 12? Positive 9. And what's the answer here? What's going to happen here? This is going to become subtract. So negative 4 minus 2. What is negative 4 minus 2? Negative 6. So our final answer, BC. Never forget your arrow is equal to 9, negative 6. No, guess what? Anybody realizing anything yet? Even with, oh, let me take out the music here. Let me see if my students thinking. Look at BC and look at AB. Anybody seen the relationship already? So you could already guess what you think they're going to ask us. They're going to either ask us if these two vectors are what? Parallel, or if the 3 points A, B, and C are collinear. Right or wrong? Even before we look at the question. Everybody seen it? Not the answer is 3, but K is 3. And I agree with you. K is 3. Everybody seen it? So let's look at what the next question is. State one geometric relationship between BA and BC. Boom. We don't know. What is the relationship, guys? The two vectors are what? Say it for me. Say it for me. What is going on between the two vectors? Excellent. So what you would do, even though they didn't say prove it, you must say BC and BA are parallel since you remember the whole thing about the kitting. So what would you write? Which one is the bigger one? BC is equal to 3 times BA. Let me just move this bracket. BA. Hence what? K is equal to what? 3. We just answer CXC question there. That's how a CXC question comes all the time. How y'all feeling? We done vectors, you know, that's it. That's one part. That's one major part of vectors. Looking for the two vectors, finding them, determining what is the relationship between them. And there's only 2 options. It's either both of them are parallel or the 3 points are collinear. So you will never hear vectors are collinear because that don't make sense. It's only the points are collinear, but the vectors are parallel. Everybody with me? And to prove it is the same steps. You use the same steps to prove that 3 points are collinear and two vectors are parallel. All right. So look at that. We just answer a whole question. Now let's look at the last part. Oh, look at this here now. Look at this here now. 3. If point M, remember I told y'all that is always do this. If point M is the midpoint, how do you find the midpoint of anything, my awesome people? How you find the midpoint of something? What the midpoint means? What number you got to use to find the midpoint? If you're finding something in the middle, what do you have to do? You got to do what? Divide by. You got to divide by 2. Agree or disagree? So before we even get to the question, look at what they gave us. They said that if point M is midpoint of AB, oh, did we find AB? We didn't find AB, but who did we find? We find BA, but we couldn't find AB easy by doing what? Just multiplying by a negative sign and switching it. Everybody with me? So they're saying find the coordinates of M. So it's 2 things you got to do. So let me zoom out there. Because before you could find the coordinates of M, what must we find first? We must find AM, right or wrong? Remember we did that before? So what I'm going to do to save time, I'm just going to go straight into looking at the example itself. So let me see if I can find it. Look at it right here. This is the solution. So look at that. What I love about this is that they just assume that AB and BA is the same thing. So look at what they did. You remember we found BM, BA? Agreed? So what they did, they drew the picture so they could see that it's halfway. And because it's halfway, what they use is BM, because the truth is you don't even need to find BA. So it was something that could confuse you. Everybody understand what I'm trying to say? If something is halfway, look at that. If BM, if M is halfway, BM and AM ain't gonna be the same thing, because this distance here is the same distance here. So what they did, they just found half of BA one time. Everybody with me? So BM is equal to half of BA, because it is what? In the middle. And look at what you realize here, BM, BA. You see the connections? So let's go. We found BA before, so we need to find a half of 3, 2, negative 2. All you had to do was divide 3 by 2. Everybody with me? So you would say 3 over 2 and negative 2 over 2. So what do we get? We get 1.5 and we get negative 1. But guess what? Did the question just ask us to find BM, or it asked us to find the coordinates of M? Anybody remember what the coordinates of M mean? If something asks you to find the coordinates of M, what you're supposed to be looking for? In OM. Remember, that's the first thing I teach y'all. If you want the coordinates of any point, you find OM. So guess what we got to do? Anybody could tell me what we got to do? It's a combination of what we just learned. What can I use here to get OM? Let me see if we're thinking. We know that we need to add 2 things. We know the first one got to begin with an O, and we know it got to end with an M. But which ones? What can we use? What do we have? We ain't got BM now. Right or wrong? And don't we have OB? So we got BM, because that's what we just find, and we got OB. Everybody with me? I just speed it up because I know y'all would have figured it out eventually. But just for us not to spend all night here. But everybody see that? Remember, we just find BM. And what do we have all along? We had OB. We had OB from the jump. Right or wrong? We ain't had OB from the jump. So look at what they did here. Same thing again. Look at here. OM is equal to OB plus BM. And you just add the 2. You find your answer, and that's the coordinates of M. CXC question there again, we just do in 5 minutes. Everybody see that? So I think I've gotten you to a very strong place. So your job is to look at this. Oh, let me just go over this one quick, because most people didn't watch the video before. Anytime they ask you to find the length of the size of any vector, you use this formula. The square root of x squared. So whatever your x is, you square it plus the square of y. Everybody with me? And like I said, the video that we did on Thursday covers all of this as well. So make sure you find some time to look at it. Everybody with me? But everything else from here is the same thing. Look at that. RJ is equal to RO plus OJ. So as you see, you would realize why I spend so much time focusing on making sure y'all understand the formulas, the triangular law, because it is the foundation of everything on the vectors. So since we're going to end here, let's just scroll through. What do you realize again? Look, the formula here again. You want OT. What is OT equal to? OR plus RT. OT, R in the center. All right. This here is similar. This is the only thing that I need to touch on. I have not seen one question where they brought a parallelogram, but guess what? It's still simple, because check this. If you got 2 vectors and they're parallel, look at that. Boom, boom. And you have another 2 vectors that parallel, which is what? This here. What shape you realize going on here? To remember. Everybody see that? So these 2 lines and these 2 lines and this line and this line. Once they're parallel, you know what law we use when two lines are parallel. They just a multiple of each other. So, yeah, with me, y'all can hear me? I don't even know if my mic working still. It working? Okay, good. So we're gonna end here today. And so your job is to take what we've done, guys, and revise these harder concepts. And how I recommend you do so, look at the questions and see if you can understand what they're asking you for. If you don't know, go and look at the solutions and then see where you could pick up and where you can't pick up. The only thing that I want to do that I kind of had is this last one, but I'll do this on Thursday. Yeah, I realize it's the same thing that we were doing before, just a lot harder with the whole A plus B. If you go this direction, is minus B, but if you go this direction. So that's the same thing we've been doing before, but it's just at a higher level of difficulty. So our focus is going to be this next week and some past paper questions. So my awesome people who were able to make it to the end of class, out of 10, how you feel about everything we did today in terms of understanding? Looking good, looking good. I'm actually very impressed with you guys. Keeping in mind, you know, how I teach. I don't like spoon feeding you every single thing. It's important for you to learn how to think. So, oh, I'm going to send you the location. Usually, private candidates go up the college, up CFBC. Because of COVID last year, they end up splitting it up and they sent some students to different locations. So as soon as they email it to me, I will let you guys know. I just recently went and picked up the official registration form for everyone. I have to submit your SBAs by ending of March, April. Like I said, you already got your 20 and 20 for your SBA. And the compromise there is if I do it for you, what should you be doing with your extra time? Seriously, what you should be doing with your extra time? Practicing. And how should you be practicing? Use the website that I sent, the FastPass website that have the past papers with the answers. That is what everybody should be looking at right now. Go through each question, see what you know, what you don't know. Learn things as you go through the solutions. That's what you are supposed to be using your extra time with. All right. So that's it for class today, my awesome people. I will see you guys on Thursday. Have a good evening. Pick up yourselves.